Good day, my listeners out there, students. Thank you very much. In our last video, we looked at chemical equilibrium, and I appreciate the feedbacks that I've got so far, the likes, the appreciation, and wow, some of you said these videos need to keep coming, and that is why we said, oh, there is no time to waste. We have to start up with the next video. Now, in our last video, I told you that we'll continue with chemical equilibrium, considering the factors that Le Chatelier's gave to us, looking at the change in temperature, change in pressure, and change in concentration. Now, but before I do that, I want you to know out there, chemistry is never abstract. The way they teach it, some places you tend to feel as though chemistry is so abstract, it does not deal with our day-to-day lives. But no wonder someone asked me that question. What is the application of chemical equilibrium to our everyday life? Wow, so many applications. I'm just going to mention some of them. Now look at even in economics, look at the aspect of demand and supply. That is equilibrium in practice. That's equilibrium in practice. Now if you look at even in your homes, if you look at heat coming in and you have the cool breeze coming in, you see that the overall temperature remains constant as long as you have heat and the cool sensation coming in at the same time. Of course, that's the law of mass action, if you remember. Yes, the same reason why I tell students, I tell people, if you want to cook in a poorly ventilated area, that is terrible for you. That is terrible for you. Now, because in your cooking stove, remember, carbon 2 oxide is liberated. And you know how poisonous that is. Now, why is it poisonous? It will combine with your hemoglobin to form a very terrible chemical compound called carboxyhemoglobin. And remember that hemoglobin helps in the transport of oxygen, while of course myoglobin stores oxygen. Now, if our hemoglobin that is supposed to be responsible for transporting oxygen combines with carbon 2 oxide, forming that chemical complex, carboxyhemoglobin, it prevents oxygen uptake in our body, and of course that will lead to sudden deaths. And that is why please do not cook in poorly ventilated area. If you have a kitchen, your kitchen should have several doors, windows, where you have inlet and outlet of air. And trust me, if you don't have enough windows in your kitchen, break that window and create one. I hope you got that. You can break it and create one. That I said so. Now take notes. Now let's just go straight to the factors affecting chemical equilibrium. We looked at 3 factors: the effect of temperature, the effect of pressure, and of course the effect of concentration. Now, temperature. If temperature must affect any chemical system, you must consider these 2 things. Is it going to be an endothermic reaction, or is it going to be an exothermic reaction? Now, what is an endothermic reaction? It is simply a reaction during which heat is absorbed from the surrounding. While of course, exothermic, that's just the opposite. An exothermic reaction is one during which heat is liberated to the environment. Now, any reaction that will lead to heat being absorbed, that is the part that the reaction is favored. Now, for example, look at the Haber process, for the production of ammonia, where you have nitrogen gas combining with hydrogen gas in a forward and a backward reaction to give us ammonia. Now, the forward reaction is exothermic. The backward reaction is endothermic. Now, that reaction gives rise to about minus 92 kilojoules per moles of energy. You look at that, that is pretty big, for a negative value, minus 92 kilojoules per mole. Now, that's an exothermic reaction. It shows that heat is given off in that reaction, and that is why you have the negative sign in front of the enthalpy change. Now remember what I said, that any reaction that leads to an increase or absorption of energy, that is the side that reaction faces. Now that means in an endothermic reaction, the forward reaction, remember heat is absorbed, that means increase in temperature will favor the forward reaction. And of course, a decrease in temperature will favor the backward reaction. Now the reverse is the case for an exothermic reaction. An increase in temperature in an exothermic reaction will favor the backward reaction. Remember, that is the side that heat is absorbed. We favor the backward reaction. While a decrease in temperature in an exothermic reaction will favor the forward reaction. Now, but when we come to a change in pressure, now for pressure to affect any chemical system, two things are considered. Of course, the reactant and product, you must have a gaseous molecule. And of course, the number of moles of reactants and products must not be the same. If they are the same, pressure cannot affect that system. So these are the two factors that are considered. The number of moles of reactant and product must not be the same. And in your reactant and product, gaseous molecules must be involved. Now, if these two criteria are met, an increase in pressure will favor the side with a lower number of moles. Now, why is that? Why is that? Let me take you back to your chemical laws. If you remember your Boyle's law, that wonderful scientist, a great guy, Boyle's. If you remember what he stated, he said that as the pressure is increasing, the volume is decreasing. Yeah, inversely proportional. Pressure and volume are inversely proportional. You understand? As the pressure is increasing, the volume is decreasing. As the volume is increasing, the pressure, of course, is decreasing. Now, remember what I said. Chemistry has application in everyday life. Now, Boyle's law, remember, if you want to pump your tires, that is just Boyle's law in action. As you're increasing the pressure, the volume is decreasing. As you're decreasing the pressure, the volume is increasing. Yeah, that's chemistry in action. That is why I told you from the outset of this video that chemistry is not abstract. Anyone who teaches you that way, come on, ask that guy a question. Why teaching me chemistry as though it's abstract? It's not. It has an application in everyday life. And as you're going to see the different videos that we're going to make, I will tell you applications of each of them. So every topic in chemistry has application in everyday life. I hope you got that. Now, that is pressure. So as you increase pressure, it favors the side with a lower number of moles. While a decrease in pressure will favor the side with a higher number of moles. Just as you have for your Haber process. I hope you got that. Now, for the last factor that Le Chatelet has considered, that is a change in concentration. If, for example, I still want to use my Haber process where ammonia is produced. Now look at that. Nitrogen gas reacting with hydrogen gas in a forward and a backward reaction to give us ammonia. Now what do you think will happen? Remember, that system is at equilibrium. Yeah, it's a balanced system. And that is why you have forward and a backward reaction. I hope you got that. Now, if I decide to remove nitrogen, then come on, I'm not doing the right thing. I have distorted equilibrium. Equilibrium has been distorted. I have removed one of the reactants. Now something is going to happen. Remember what I told you about me ingesting terrible food that has great whitish substance, muco around it, and I put it in my mouth. Oh, how disgusting that is. Remember that my system was initially at equilibrium. Now I took an external constraint, which is that spoiled EBA. Pardon me for using that. Spoiled EBA. I put it in my mouth in a system that was at equilibrium. Oh, I started throwing up. Now the throwing up process means the system is telling me I want to return to my state of equilibrium. I want to go back to being balanced. Yeah, everybody wants to be balanced. Of course, that's why people get married. Never mind. Now, everybody wants to be balanced. Even your chemical system wants to be balanced. Now, that's the same thing that will happen when I remove nitrogen from that chemical reaction. Removing nitrogen, I have distorted equilibrium. So the system will try as much as possible to bring back that nitrogen. And that is why if I remove nitrogen, the system will favor the backward reaction to make up for more nitrogen. I trust you guys are getting this. Yeah. Now, if that same reaction, the Haber process, I have nitrogen plus hydrogen, forward, backward to give me ammonia. What do you think will happen if I keep removing ammonia as it is formed? Yes, that means I am affecting the forward reaction. The system will try as much as possible to make up for ammonia. That means the forward reaction will be favored. I trust you understand this small, simple analogy I gave about removing and adding. Now, some textbooks will tell you some things about catalyst. Yeah, a catalyst, what it does is it only decreases the activation energy. When we come to other topics in chemistry, I will explain activation energy. That's the enemy of our reaction. I hope you got that. Now this is where I stop for this video. Remember, the next video will come up, and if you're interested in us giving you an insight into specific topics, you're very free. Send in your messages that you want this topic to be treated, and it will certainly be treated. Now remember, go to our Facebook page, the Simplifier One rather. Go and like our Facebook page, share it, and please, our YouTube channel, please subscribe to our YouTube channel. Remember, the Simplifier One. Thank you so very much for listening. I will see you in our next video. Bye.